Welcome back to Quantitative Reasoning Online, Lesson 15b, All Things in Moderation. Question 1 and Question 2. So let's go look at the questions. So let's consider the following studies. Complete part A through D. Oh, 4 parts. A researcher randomly divides 200 students into 2 groups. First group was told not to exercise. Second group told to exercise at least 5 hours per week. At the end of 2 months, heart rate of each participant in each group was measured at rest. It was found that the group that exercised 5 hours a week had a significantly lower heart rate. 2 was a researcher gathered 200 high school students randomly and asked them, survey, how long they exercised each week and then measured their heart rates at rest. It was found that students who exercised at least 5 hours a week had a significantly lower average heart rate. So which was experimental? 1 or 2? Remember, experimental means manipulating your data, a variable, also known as has a treatment, which is what 1 is. And we actually have a control group. The control group being the not exercise. Here's my control. And the second group was my treatment group. This is basically just a survey. Let's explain to response variables in the studies. We varied exercise we measured heart rate. So vary would be the explanatory, and the output, the response. So which one? Exercise time, heart rates, student amount of exercise, heart rate, exercise time. A. So with variable are quantitative or categorical qualitative. Again, quantitative is measurable. Category and qualitative, it's a descriptor. Tells you something about the subject. In both cases, exercise time is measurable and heart rate is measurable. And if it's measurable, it's got to be quantitative. It would be A. And identify a flaw. C. Participants should not have been told how much to exercise. Well, that's a treatment. Not been randomly assigned to groups. Oh, that's just good practice to minimize bias. Participants' heart rate should have been measured both before and after the study. Yes. Basically a baseline. So A. Okay, in testing the effectiveness of a new vaccine, suppose that researchers use males for the treatment groups and females for the placebo group. What is confounding and how would it affect such an experiment? So, males get the drugs, females get a placebo. Not very representative of the population. So confounding is a process of making a sample more representative of the population. Nope. Confounding is when the researcher and subjects in a study do not know who is in the treatment group and who is in the control group. Now that's called a researcher and subject. That's called a double blind. Double blind study when both the researcher and subjects don't know the information. And that's bias control, which could minimize confounding. Confounding is the process of eliminating all differences between the groups in a study so that the only difference that remains is the factor of interest to the researcher. Well, that's just experimental design. What you want to do, you want to minimize differences. You want to get it down so that what you are looking at, explanatory, does give you a response. So confounding is a mixing of effects from different factors, so the effect of the specific factor being studied cannot be determined. I mean, that alone would sound, just that definition sounds a little confounding. It's got to be D. A, B, and C are good things we want to do. What we do want in a good experiment. And what this said. Now, how could this affect the experiment? If males are given treatment and females are given placebo, a researcher will not know whether the effects are due to the treatment or the sex of the participant. Sounds a little confounding there. That's potential. Confounding would make the results of the experiment more representative of the population. No, confounding confounds, does not make results representative. Researchers will be confounding as to whether the male or the females are receiving the treatment. No, that's basically blind study. If males are given treatment and females are given placebos, a researcher will be certain that any difference between the two groups are attributable to the treatment. If males are given treatment and females are placebos, a researcher will be certain that any differences between the two groups are attributable to the treatment. That doesn't make sense. It has to be A then. Just think about it. Male treatment female get placebo. And let's just say it's a vaccine. For, I don't know, a vaccine. So if the males respond detrimentally to the vaccine, it doesn't work, it must be because the females got the placebo. Or we make a statement that, okay, it didn't work. Females placebos, males treatment didn't work, therefore treatment won't work on anybody then. This whole issue this whole design was wrong. you want both populations look the same. So first thing to get rid of confounding is to have your treatment group and your placebo group look alike in terms of sex distribution, age distribution, general health distribution. So yeah. I mean, this is the key word here. Gotta be A. Actually, I know it is A. And with that, we are done with questions. So go and do the questions yourself now. Work with Stephanie on the workbook. PDF copy it, upload it, and then we're getting the 15B practice assignment, and I'll see you shortly or sometime in the future for 15C.